Okay, last day of review for the big test. Now remember, tomorrow's the test. If by the end of this hour, and then tonight, as you're doing your homework, which is the rest of the review, you already did the odd ones, now we're going to do the even ones. If you come back the next day and say, I need a couple more days, or not a couple more, I need another day to study for this thing, Mrs. P is going to be instructed to allow you to skip the test if you want to, but that means you'd have to take it in the morning or after school the following day. So that gives you one more night to study if you really feel like you need that. That would also free up Wednesday morning. She'll be here. Perfect person to have here for math because she's done everything you've done. She knows how to do all this stuff. So if you need help, you could ask. You could get some more help on Wednesday morning. Then you'd have to take the test by Wednesday after school. So if tomorrow you feel like I just can't take the test, I can't do it, I'm not ready, you may have one more day, but you need to take it by Wednesday night after school. All right, so here's a typical question that you ought to be able to do. And I know it's been a little while since we talked about these, so I won't be surprised if we need a little bit of help here. That spot's negative 3, 0. That spot's 3, 8. Here's the questions that we could ask you about this. Oh, one more thing. We need to know this. Let's say that's at 6, 0. I could ask you, where is this function increasing? Write me the increasing interval. The interval over which the function is increasing. I know some of you know, well, I know he's talking about this part. But do you know it's like from there to there? That's the zone over which it's increasing. Did you say from negative 3 to 3? Raise your hand if you had that one right. Awesome. Okay, now there's 2 intervals over which it's decreasing. Those are a little harder because they involve infinities. Let's see if you can handle the 2 decreasing intervals. I'm going to pause for a second while you give that a try. Okay, so you got to think of these as zones. Like from here to here, it was decreasing. But what's way over here? Infinity. To what's here? Negative 3. So from negative infinity is way to the left. Negative infinity to negative 3. Raise your hand if you had that interval correct. Okay, and then the other side? Dice of destiny. Row 1, person 3. That's you, sir. From 3 to infinity. And who had that one right? Okay, any questions about that so far? Yes? Yes, unless you write them above each other like that. If you wrote them next to each other, you should have a U in between them. Okay, what he means is if I had this, I should have a U between them. Okay, now the equation for this, hint, you need, this is not the answer. There are things like that. Every root has a special parenthesis. See if you can write me an equation like that. That's not the right answer right there. But something like that. Write an equation for me. Pause for a second. Let me try that one. Okay. So I saw a few variations of things that people were doing wrong, but I'll just show you the right answer here. You should have said that I have a parenthesis for this, and it was at x plus 3. Do you get the negative 3 would make it equal 0? All right, so x plus 3, and it's bouncing there, which means it's called a double root, and that means you need a squared here. Raise your hand if you had a squared on that one. A lot of people remember that. Good. And then this last part, x minus 6, and then what? Do I need anything special for this? Is that bouncing? Is it doing a triple root? No. It's a single. If I put a 1 there or not, it's okay either way. But wait, somebody smart caught something else that about half the class didn't. Yes? You did what? A negative. Sorry, they both thought they were being called on. One of them said, it needs a negative. Why does it need a negative in the front? Yes? Actually, the left side has nothing to do with it. It's just the second thing you said. Because it's going down on the right. It doesn't matter what the left does. It's if the right side's going down, you need a negative in front. All right. One more like that. This one's going to have one of these in it. Special one at, well, you can tell where it is. And this one's at 8. What's the equation for that one? It's pretty amazing that I can give you that little picture. It's only got one number on the whole thing. And you can write me a complex equation for it. Tell me something. Okay, why did you notice, or no, I shouldn't say that. How could you tell it was negative? That's going down, had to be a negative. How many of you actually caught it this time? You had the negative there. Okay, good. All right. Miss LD, what do you think I should do for the rest of it? X to the third. Now, some people will say x plus 0. Isn't that the same thing as x? Yeah, and I like it better if it's just x, but I would accept x plus 0. All right, awesome. And why to the third? Because it has this weird little swerve shape. I call that a snake through as opposed to a bounce, as opposed to a cut through. It's snaking through, all right? Would you recognize it if it was going the other way? If I had a function that was going like this, do you get that that's just a backward snake, still degree 3? If on the test you are not sure if that's a snake or not, you can ask us. If you're looking at it and you're like, I can't tell by the way this is drawn, because see, that would be a good question. Some kids that don't understand this stuff might not even think to ask. All right? This one's just a cut through. So it's degree 1. But this one, if it had been like that, that would be a degree 3. Just like this one's a degree 3. Okay, so one more. That was x to the third, and then this is x minus 8. And there's nothing special about this. It's not bouncing. It's not snaking. That's degree 1. Raise your hand if you had that one right. Awesome. Okay. Now that's, well, wait, one more thing. They could ask you this. This root, single, double, or triple? This root, single, double, or triple? This one, triple, this one, single. And you know doubles look like a bounce, right? Okay. All right. So let's practice that a little bit. There's root A, B, C, D. What's root A? Single, double, triple. Single, how about B? Single, how about C? Triple, how about D? Double, all right, good. Okay, now that's the easy part of the test. Now, it's factoring stuff. Let's just ease you into this so you don't like pull a brain muscle or anything. If I had to factor this, go ahead and factor it. That's back to easy factoring. But yes, in the middle of a really hard problem, you might be factoring this as just part of the problem. Do you know what I mean by that? Like, let's say I had a problem and I'd already factored this part and it came down to x plus 6. And then I had all that part left. See what I mean? And if I left this as my answer for the factored form, not factored all the way. So this one would be x plus 6 and x plus 5 and x plus 1. Raise your hand if you had that one right. Awesome. What would be the roots? The roots are the zeros, right? And the zeros make it equal 0. So -6, -5, and -1. And are they real or imaginary? Those are all reals. All right, so imagine for a second that you got done factoring and you got this. Real or imaginary, or is there both? There's both. Find me the reals, and I'll put that on the top line. This was factored form. And then they'd say, what's the reals? And what real roots? And then imag roots. Hint. This, set it equal to 0 and solve the equation. Make it equal 0 and then just solve. The first step is subtracting 1 and you go from there. All right, for the real root, it's just x minus 7 equals 0. X equals 7. With me so far? The other one. X squared plus 1 equals 0. X squared equals -1. Ooh, that's getting messy. I'm going to go down here. X squared equals -1. Square root, square root. Square root of a variable is absolute value. Square root of -1 is I. Finish it off. X equals I. X equals -I. Always there's somebody who asks me, can you say plus and minus I? Yes, you can. If you want to write them out separate, you can, or you can put them together. Now, one thing about these imaginaries, if you ever write down that there's only one imaginary, it's wrong. I guarantee you. You know why imaginaries always come in packages of 2? Because of the quadratic formula. You know how in the quadratic formula is a plus and minus the square root, Well, there must be a negative underneath that square root, right? And then there's a plus and a minus in front of it in the formula. Okay, there's always going to be 2 imaginaries. If there's ever just one, you're doing something wrong. Okay, you'll always have 2. One's plus, one's minus. The other way I could say it is that you're always solving something with x squared equaling a negative. And in that, you're always going to be square rooting a negative, which means there'll be an I involved. So the imaginary ones have an I. You know, on the real and imaginary, I get this all the time. Kid writes this. The real one, they'll say x equals like 7. And down here, they'll say x equals square root of 2. Guaranteed can't be right. Why? Because square root of 2 isn't imaginary. If there was an imaginary, it would have had to have been the square root of -2, and then you'd have to say I root 2. You know what I mean? If you don't have an I on that line, you're being dumb. You can't put an answer that's not imaginary on the imaginary line. I have to mark something wrong for that. All right. Next kind of factoring is this. No extra hints. It'll just say factor. Some of you are thinking of busting out synthetic. Don't do it. This one can be factored just with 2 parentheses. This is one of those that's so easy, but yet some people just make it into this really like, oh, it's so hard. It's not. It's just x squared and x squared. And then what multiplies to 1? 1 and 1. Done. That's it. How could I know I'm right? Because I can multiply it back out. And this times this will make x to the 4th. And then the outside one and this inside one, they would add up to 2x squareds. That's what I wanted. And then 1 times 1 is 1. So yay, it worked. So one more like that. X to the 4th minus 9x plus, or squared, sorry, plus 8. Factor it. Back to that one. Can't be done already. I just got done writing it. Okay, did you have x squared and x squared? How many had that part right? Cool. Did you have -8 and -1? How many had that part right? Awesome. Who knows that that answer is actually wrong? Because there's something else you should do. Oh, only 4 of you. You all just lost half credit because you didn't factor it all the way. Look for what can be factored more. Okay. It's not this one. That can't be factored more. But this one could be factored more. X plus 1, x minus 1. X squared minus 1. Factors. X plus 1 and x minus 1. I can prove it. X times x makes x squared. That makes -1x. That makes +1x. Those cancel. And then that one makes -1. X squared minus 1. Yes? Ooh, good question. So here's the question. Is this an okay answer or not? And I agree with your question because it's a good question. He knows that you could factor this further if you used the square root of 8. You don't have to. You can stop right there. But let's just watch him do it. If you want to go further, it's actually kind of cool because then you'll get your roots easier. Would you please finish it and tell me? This is optional, but smart. Yep. You just use the square roots of both. Square root of x squared is x. And the square root of 8 is square root of 8. And then why is that any better? I know some people are going to be like, that's stupid. I don't have to do it. I'm not doing it. But what's better about it is that if you want to know the roots, you can just go -√8, +√8, -1, +1. X equals all those things. Did any of them have a square root of a negative? No. Don't think square root means imaginary. It doesn't. Square roots of negatives. Yes. Good question. It would be best if you did. I didn't want to throw off the... Yeah, you're right. That is another thing we could do here, but I don't think I would mark that one wrong. All right, moving on. How about synthetic? Do you think that's a big deal? Yeah, it is. All right, so let's say I had this one. And I would say to you, first of all, you can do this with long if you want to. I'm going to set it up with a long. I personally would switch it to synthetic if I were you, but you have a choice. If I said, is x plus 3 a factor? You'd have to answer it by saying either yes, and here's the 2 factors it factors into, or you'd say, no, I can tell it's not a factor because I got a remainder. Hint. I would use this. Pause for a second while you try to finish this off. Again, don't just say, oh, I got a 0. You got to say what the factors are then. If you get a 0 remainder, what are the factors? Pausing. Okay, if I drop it like it's hot, multiply and add and multiply and add and multiply. It worked because I got a 0 at the end. Raise your hand if you got that part right. Awesome. And what is the answer? I hope, I really, really hope that you knew that this can come down and make an x plus 3, and that this is the x's and the x squared, so it's x squared minus 8. And holy cow, isn't that the one we just did a second ago? Yes. I just wanted to show you that you can do this with synthetic too, but you need to know what the root is. Now, some people are going to say, well, wait, Mr. Server, I can just factor that by grouping. You're right. Let me show you that skill. Whole tons of factoring skills to know. 2x to the third plus 4x squared minus 9x minus 18. I don't even have to tell you what the root is, and you can do factor by grouping. I like to call it divide and conquer. That's where you go like this. Divide it up the middle, factor the left side, factor the right side, and then factor it again. Pause or give that a try. Okay, divide and conquer. Did you get it? I know some people don't catch this. There was a 2 in both of them. And then what else was there? X squared in both of them. And that leaves you with x plus 2. And over here, a negative 9, x plus 2. If these aren't matching, you know you're doing something wrong. How many of you got them to match? You got that far at least. Awesome. Then this next part also is a stretch for some people, because it's really hard for them to see that that and that are a factor that can be pulled out to the front. And x plus 2 then is out in front. And what's left after that is this and this go here. There. That's factored all the way. And some smarty pants is probably going to say, can I factor this further with using square roots? Yes, you can, and that'd be awesome, but you don't have to. What would you have to be able to do? You'd have to be able to say, what are the roots? Well, this one's super easy. It's negative 2. Would you just find me the roots for that? Hint, it involves a fraction and a square root. Pausing for a second. Okay, let's see if you got this part right. I think the easiest way on these is to just simply say equals 0. Do one little step at a time. Start with your add subtracts. I'm adding 9. I'm going to divide by 2. And now I got x squared equals 9. Square root, square root. Oh, sweet, x equals 3. No. The absolute value of x equals 3, so then there's two answers. X equals 3, x equals negative 3. 9 over 12, man, I'm sorry. Whoopee, whoopee, sorry. Whoopee. 9 over 2. There we go, and that messes everything up. I apologize. Okay, so now I got absolute value of x, square root of 9 halves. Then I need two answers for that. X equals plus and minus the square root of 9, which is 3. So you could put it 3 over the square root of 2 if you wanted, but I forgot the 2 on the bottom. You're right. There. Some of you are smarter than the math teacher. How many actually had that right where I was screwing up? Okay, good job. Okay. You want to know the hardest thing of all? The hardest part of all is when they don't tell you what the possible roots are, and they just give you a big, long, nasty equation and say solve it, or sorry, factor it. All right, and if they don't tell you what the roots are, I want to give you a quick reminder how that works. This is not the super hard one. I'll get that up in a second, but let's say I had this. Do you remember that deal where the possible roots, the things that could go in the little box, you know, if you're going to do synthetic, what numbers could it be? Well, it's plus and minus the factors. And what are the things on the top? The factors of the constant. And what are the things on the bottom? The factors of the lead coefficient. All right, and so here we go. The factors of the constant are 1 and 2 and 4. The factors of the lead coefficient here are 1 and 5. Don't forget the plus and minus. And divide everything by 1 and divide everything by 5. And yes, there'll be fraction answers. I did tell you that it'd be unlikely that we would ever pick one of those to be the root, because fractions are a real pain to put through synthetic. So it's plus and minus 1 divided by 1, which is 1, 2 divided by 1, which is 2, 4 divided by 1, which is 4, and then I do them all with 5. 1 divided by 5, which is 1/5, 2 divided by 5, which is 2/5, and 4 divided by 5, which is 4/5. Holy smokes. Those are all the things that could possibly work. Now, I want to give you a huge hint. If you're going to pay attention, this will be really, really handy. Do you remember that you were told a long time ago that calculators are going to be allowed on this test? How could I use it right now to narrow down my list of 1, 2, 3, 4, 5, 6 times 2 is 12 possible things? Okay, here's how. Can I have a calculator? I couldn't. Can I have a calculator? You can have a calculator. All right. Okay, if you don't want to use a calculator, fine. You can't use a calculator. But no, you can. You can use a calculator. I checked with a friend. I was planning on giving it to you without a calculator. And I checked with one of my friends who teaches this class, and he's like, oh, yeah, kids you can use a calculator. I'm like, well, if he's letting his kids use a calculator, I'm going to let my kids use a calculator. But here's the only way it would help you. Really. Like, if I just say graph this, does it, like, fix your problem? No, but, think about it. If I graph it, and it turns out to look like this, do you get those are the ones that work? So it could be handy to narrow down your list of 12 things if you, and I'm warning you, it's not always easy to find that spot. When you hit graph, you got to adjust your window and stuff. It's a kind of a pain. But if you graph it and you go, oh, it's touching at -3, the -3 is the number you use in synthetic. Your calculator will not factor for you. And since this test is pretty much a factoring test, don't think, oh, so that's going to make it easy. No, but it will narrow it down so you only have to test 1 or 2 things with synthetic. All right. So, question.
Okay, so if it was a -3, which one would you put?
Okay, so first of all, it can't be -3 because that's not one of the possibilities. All right, so I was just making something up. Let's say it said -2 right here. Well, then you would know that -2 is the thing you should do with synthetic. You know what I mean? You'd use the -2. All right. So let me give you one that's like that. Are you ready? Are you really, really ready? All right. The scale, just use 1. All right. So here's your big problem. Notice me not telling you, check and see if 2 works. I'm not going to tell you what to check. You have to use your brain and know how to do that little factors of this over factors of that thing. Then you can use the calculator. Once I got it narrowed down to like, oh, it's only these 6 things are possible, use the calculator and see which one it actually is. Then do synthetic. This is going to be a beast, but it's our last one. I'm going to pause for a second. What do you give this a try? I'll come back after a few seconds to give you the list of possible roots. Okay, what are the possible roots? Plus and minus, the factors of this, 1, 2, and 4, over the factors of that, which is just 1. And therefore, it's 1, 2, and 4, plus and minus. But somebody in here just graphed it a second ago. How did I get that? You didn't get that part? That came from the factors of the constant up here and the factors of the lead coefficient down there, and I divided them. Now, a kid made the graph, and it roughly looked like that. I know I'm wrong, but it touched like there. Doesn't that give you a hint that the answer is a negative number at least? Do you get what I'm saying? The root must be negative something. And did anybody zoom in on it enough to tell, was it negative 1? I think it was negative 1. Would you please test negative 1 then? That would be a logical one to start with. And if it wasn't negative 1, maybe it's negative 2. But the graph tells me it's negative. Now, you don't even have to do that graph thing. Awesome, but for right now, would you start with negative 1? It's okay. You can't use decimals in the test, no. Yes. How do I know what the graph would look like? You have to use a graphing calculator. So you just use the calculator, type it in, and boom, it graphs it for you. Okay. Here's how I would test negative 1 now. 1, 5, 3, negative 5. You think so, huh? It worked. Boom. If you made a mistake in there, it didn't work, but it worked. So negative 4 worked. Now, somebody else might have thought negative 1 wasn't going to work because they found something else that also worked. Remember, this is a list of things that could work. Did we say they were all going to work? No. Did we say that only one was going to work? No. So more than one thing actually works. What else worked? Somebody help me. Yes? Negative 4 also worked. That means that you could have done it 2 different ways. But wait, I know some of you in a moment are going to leave, and I totally get that because it's time. But I'm going to finish this problem because we're doing a video here. And those of you that want to see how the hardest question is done can watch this tonight if you want to at home. All right? Your homework is to finish that review assignment, and you will be Dropboxing it tomorrow for points. So do it and check it with the key. All right, have a great day. All right, I'm going to finish this problem up. X plus 1. This part, this is x's, x squareds, x to the thirds. So we have x to the third plus 4x squared minus x minus 4. There, that's partially factored. Now, somebody figured out that negative 4 was also a root. So I'm going to take this now and use the fact that the graph had told them that negative 4 was a possible root. And I'm going to do synthetic again. 1, 4, negative 1, negative 4. Drawing a line, drop it. It's a 1, negative 4, adding is a 0. Multiplying 0, adding is negative 1. Multiplying is positive 4. And look at that. I got a 0 remainder again. So it worked. I'm going to bring this down, x plus 1. I'm going to bring this down, x plus 4. Then I'm going to bring this down. That's the x's, that's the x squareds, and it's x squared minus 1. And then this has got a vicious twist. This can be factored one more time. So final answer, x plus 1, x plus 4, x plus 1, and x minus 1. That is about as intense as they can get. That's factored all the way. There are 4 real roots. And yes, one of them is a repeat of the other. That counts as 2 roots, but both of them are negative 1. All right. That's about as tough as it could get. And that's all I have for you for the video for today.